Hello everyone, welcome back to Infinity Physics. In this lecture, we are going to discuss about power of lens. Now, before defining power of lens, let us try to understand what is the exact meaning of power. So, suppose I have two convex lenses, one with focal length, let us say very small focal length, very short focal length, that is of 10 centimeter for our convenience, and I am having another lens having a large focal length. For example, let us say the focal length of 30 centimeter for our convenience. Now suppose I introduce a ray, that is a ray incident on the lens which is parallel to the principal axis. So if the ray is parallel to the principal axis, then after refraction the ray will pass from the principal focus. Similarly, if I make a ray passing or incident parallel to the principal focus, incident parallel to the principal focus on the lens, then after refraction the ray will pass from the focus. For this lens the focal length is 10 centimeter. For this lens the focal length is 30 centimeter. Now observe the degree of bending. In which lens the degree of bending is more? See, here the ray was actually passing in this direction, right? Actually it was passing in this direction. We have put here a lens, and due to that lens the rays bend. Now this angle and compare this angle. Here also the ray is passing parallel, but due to the lens it bends. In which case the bending is more? Here, let us say this angle is A and this angle is B. Randomly, we can say anything just for our convenience, for understanding. Here, the focal length F is shorter, very short. Here, focal length is large. For smaller focal length, the degree of bending, the power of bending, the ability to bend the light, the ability to refract the light is more, while the lens having larger focal length has power to bend the light is less. We can say for shorter the focal length of the lens, larger is the bending. For larger focal length, bending is very smaller. If the focal length is very large, for example, this is not the focal length, then in this case, if the focal length is very large, then what will happen? The ray is actually going like this. Then after refraction, the ray will pass from that focus. Let us say that is the focus. Then in that case, what will happen? The ray, see the bending, very small bending. So as you increase the focal length, the bending becomes smaller. The converging power. This lens has ability to converge ray is more. Here what is happening? The rays are converging at this point. So if the focal length is shorter, then the ability of the lens to converge the ray is larger. If the focal length is large, then ability to converge the ray is very less. That ability is called power of lens. So, what is power of lens? It is ability. It is ability of a lens to converge or diverge. Ability of a lens to converge or diverge the rays of light. Very simple definition. Ability of a lens to converge or diverge the rays of light. If its ability is large, higher, then the power is large. If its ability to converge, its ability to bend is less, then its power is lesser. Now let us understand same example in the case of the concave lens. So suppose here we have a concave lens having focal length, let us say very small. The focal length of the concave lens is towards the left, right, the principal focus. So here we have a very short focus, and let us take another lens, this lens having a very large focal length. What will happen? The parallel ray after refraction will diverge like this, will diverge after refraction. The ray will diverge like this. See, the ray will diverge like this. Here, this is parallel. What is the angle of divergence? So here, what is the angle of divergence? See, for the shorter focal length, the deviation or the change, the bending away from the normal, the bending is larger, right? Here, the bending is smaller for the larger focal length. So for the smaller focal length of a concave lens, the power to diverge the ray, the ability to diverge the ray is more. For larger focal length, the ability of the lens to diverge the light ray is less. See, it is diverged by very small angle, it is diverged by very large angle. So the smaller the focal length, larger is the bending, larger is the deviation. Ability of the lens to deviate, to diverge the ray of light is larger for shorter focal length. And the ability of the lens having larger focal length to diverge the light ray is less. So we can say if focal length is shorter, then divergence, then the divergence or convergence, in case of the convex lens, the rays are converging. So if focal length is shorter, smaller focal length, the divergence or convergence, this is convergence, right, is very large. For if focal length is large, here if focal length is large, then ability to diverge or ability to converge is less. So we can say that what is the power of lens? The power of lens means it is the ability of a lens to converge or diverge the rays of light. So here for the shorter focal length, the ability is large. Shorter focal length, ability is large. So shorter focal length, power to diverge or power to converge is large. It means if focal length is smaller, power is large. What is the relation? There is an inverse relationship between the focal length and focal length, we have small f. There is an inverse relationship between the focal length and the power of lens. If focal length is shorter, the ability to converge, the power of lens is larger. So we can write P is proportional to 1 by f. If this value is smaller, for example, for a lens having 100 focal length, just for our convenience, or we can say for lens having focal length of 2, the power is 0.5. Now for lens having focal length, let us say 10, so power is 0.1. See, for smaller focal length, power is 0.5, and for larger focal length, which is 10, the power is 0.1. So if your focal length is smaller, power is larger. If the focal length is larger, power is smaller. So here the proportionality sign can be removed and we can write P is equals to 1 by f. So this is our formula of power of lens. So we can write P is equals to 1 by F. So there is a new definition of power, that is power of lens is the reciprocal. 1 by F means it is the reciprocal. The power of lens is the reciprocal of its focal length. Right? So power of lens is the reciprocal of its focal length. What is the SI unit of power? SI unit? See, 1 by F. Now F we measure, it's the length. So length we measure in meter. So we can write 1 by meter. So it is meter inverse. It is the SI unit and another unit. This is the unit, but another unit that we use as a SI unit, both are right. The another unit is diopter, which is denoted by D. Diopter. Diopter. So diopter is the generally practical unit that we use in day-to-day life. So diopter and meter inverse are the same unit, their just denomination is different. So it is denoted by capital D. Now if you have convex lens, then its focal length is positive and P is equals to 1 by F. Its focal length, small f, is positive. So 1 by F will also positive. So if the power is positive, if given that the power of lens is plus 2D, then if there is a plus sign or only 2 is there, then the lens is a convex lens, because the focal length of the convex lens by sign convention is positive. So 1 by positive number, the answer will be also positive. Similarly, if you have concave lens, then in that case the focal length of concave lens is negative. So P is equals to 1 by F is also negative. So the power of concave lens is negative. So suppose it is given P is equals to minus 2 diopter, that is 2 minus 2D. So here you have minus sign, it means this lens is a concave lens. Now let us look at some of the numericals related to the power of lens. Question 1. The power of lens is given plus 2D. What is its focal length? So we know that P is equals to 1 by F. So F is equals to 1 by P. So 1 by 2, here plus is there. So it is 0.5. What will be the unit? The unit is meter. Right? Then let us look at another question. Suppose it is given that the focal length of a lens is let us say 200 centimeter, then what will be its power? This is just examples, right? So here we know that P is equals to 1 by F, but the F should be in meter. If you want the power, then the F should be in meter. Then what you can do here, 200 centimeter divided by 100, right? So if you divide this by 100, then you will get the answer in meters. So the focal length is 2 meters. So here you can write P is equals to 1 by 2. Remember, whenever it is asked to find the power, convert the given focal length in centimeter, from centimeter to meter. If it is given in meter, then don't convert it. Directly you can calculate. So the power is 0.5 diopter. Very simple. Let us look at the another question, question number 3. Suppose the power is given minus 10D. Just example, if you can take any number. Right? This is only mathematical calculation, nothing else. So what is focal length and which type of lens it is? So here f it is asked. So P is equals to 1 by f. So f is equals to 1 by P. So 1 by minus 10. So it is minus 0.1 meter. Okay, minus 0.1 meter. Answer you will get in meters. If it is asked in centimeter, then just convert it, multiply it by 100. So it is minus 0.1 into 100 centimeter, because 1 meter is equals to 100 centimeter. So here minus 10 centimeter. So the focal length of this lens, particular lens, is minus 10 centimeter. Now which type of lens it is? Here you have negative sign. Negative sign indicates the lens is a concave lens. Similarly here you have positive. See, here focal length is positive, power is positive, so it's a convex lens. Similarly this is a convex lens. Now look at the another example, that is a power of combination. If you are connecting two or more lens in telescope, in microscope, right, we are using 2, 3, 4 depending upon the length and the demand of the telescope and microscope, we are using more than one lenses. So in that case what will happen, let us look at. So suppose you have lens having power P1 is equals to plus 2D. Another lens having power minus 3D. Another lens having power P3 is equals to minus 5D. Then if you connect all these three lenses, then what will be the power of combination? So in that case, P is equals to P1 plus P2 plus P3. You have to just do the algebraic addition. So here you have plus 2, here you have minus 3, and here you have minus 5. So if you solve this, you will get minus 2 plus 2 minus 8 is equals to minus 6D. So the power is minus 6D. Now suppose if they ask what is the focal length of this combination, if you connect all these three lengths, then what is the combination or what is the combined focal length? Or it may also ask that the lens finally you will get is a which type of lens. So here you are getting minus sign. It means this combination refer to concave lens. And it may also ask that what is the combined focal length. So we know that P is equals to 1 by F. So F is equals to 1 by P. So 1 by minus 6. So this answer if you solve, you will get the answer in meter. So 1 by 6. But if you want to convert it in centimeter, then just multiply that answer by 100. So you will get the answer in centimeter. So to make it easy, I have done this. So here minus 6. Now just divide 100 by 6. So your final answer will be minus 16.66 centimeter. So here we have InText question from the textbook. Question number 1. Define one diopter power of a lens. Question number 2. A convex lens forms a real and inverted image of a needle at a distance of 50 cm from it. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? Also find the power of the lens. And question number 3 is find the power of a concave lens of focal length 2 meter. All questions are very simple from the InText question. So we will solve all three questions together, then we will look at the exercise question. So in the question number 1, it is given define the one diopter. So what is one diopter? So when the focal length is 1 meter, when the focal length of a lens is 1 meter, then the power of lens is said to be 1 diopter. In the another question, that is question number 2, it is given that there is a convex lens. So in the data it is given convex lens which produces a real and inverted image at a distance 50 centimeter from the lens. See, for the convex lens, the real and inverted images are produced towards the right side, right? And hence we have taken it as a plus 50. So suppose this is the image distance, which is plus 50 from the lens, and also given the height of the image and the height of the object, that is size, are same. So if the image is real and inverted, then this is our object, right, whose both height HO and HI are same, and the image given real and inverted. So we have drawn here. So when the height of the objects are same, then in that case the ratio of their heights, that is HI by HO, is 1. But here the height of the image is inverted, which is given in the question, and height of the object is always erect. So here we have the magnification is -1. Minus indicates the image is real and inverted, and plus this 1 sign, 1, magnitude 1, indicates the size of the image and the objects are same. Okay, and what is asked to find? Where is the object placed, and another, what is the power of lens? So very simple, we have this m is equals to -1 here, right? This is given in the question, okay, that we have to extract from the question. And also we know that in the case of the lens, we have m is equals to v by u. Therefore what is asked? U. So u is equals to v by m. What is v given? 50 divided by magnification -1. So u is equals to -50 centimeter. So the image, the object is placed at a distance of 50 centimeter, and the image is obtained at 50 centimeter, but on the other side of the lens. This is related to case number 3 in case of the convex lens. That is, when we place the object at 2f, the image is obtained on the other side on or at 2f. Now it is asked to find the power. Now we know that 1 by f is equals to 1 by v minus 1 by u. This is the lens formula. So 1 by f is a power. 1 by f means it's a power. So P is equals to 1 by V. What is V? V is 50 minus 1 by U. What is U? U we have obtained. It is minus 50. So minus 50. So 1 by 50 plus, it is minus minus plus 1 by 50. So here one thing is that here this 50 is in centimeter, so we need to convert that into meter. Now to convert that, we are dividing this 50, so we have 1 by 50. If we divide it by 100, then what will happen? The 100 will go up. So here we have 1 by 50, so we divide it by 100, again we divide it by 100. So here we have 50 by 100 plus 100, so it is 200. So power is equals to 4D. So the power of this lens is plus 4D because it is a convex lens. Now let us move to the third question. In the third question, the lens given is a concave lens. So the focal length given 2 meter, but it is a concave lens, so the focal length is -2, and it is asked to find the power. So we know that P is equals to 1 by F, which is 1 by -2, so it is minus 0.5D. Now let us look at the exercise questions. Now in the exercise, question number 16, find the focal length of a lens of power -2D. What type of the lens is this? Question number 17, a doctor has prescribed a corrective lens of power plus 1.5D. Find the focal length of the lens. Is the lens is diverging or converging? In this question, question number 16 from the exercise, it is given that the power of the lens is minus 2.0D. What is the focal length? So we know that P is equals to 1 by F. So F is equals to 1 by P and P is given minus 2. So it is 1 by 2 means 0.5. So it is minus 0.5 meter, that is 50 centimeter, minus 50 centimeter. Now in question number 17, the doctor has prescribed the lens having power P is equals to 1.5D. So in that case, what is the focal length and what type of the lens? See, whenever the power is plus, positive, the lens is always a converging lens, that is a convex lens. And what is focal length? So P is equals to 1 by F. So F is equals to 1 by P. Now what is P given? It is 1.5. So if you solve it, you will get 10 by 15. I am removing point from here. So I will get F is equals to 10 by 15 means 0.66 meter. So in centimeter it is 66.66. It is a long 6666. So it is 66.66 centimeter, or you can say 0.66 meter. I hope you are enjoying my lectures. If you have any suggestions, you can write in the comment sections. Have a nice day.